The use of local functions raises some interesting questions regarding name lookup. We've looked in some detail at the LEGB rule, which determines how names are resolved in Python when we want the values to which those names refer. However, LEGB doesn't apply when we're making new name bindings. Consider this simple example. When we assign to message in the function local, what precisely is happening? In this case, we're creating a new name binding in that function's scope for the name message to the string local. Critically, we are not rebinding either of the other message variables in the code. We can see this by instrumenting the code a bit. Now we're actually calling the functions enclosing and local. Again, local is creating an entirely new name binding which only applies in the context of that function. If we run this code, we'll see that neither the global nor enclosing bindings for message are affected by calling local. In earlier courses, we've discussed Python's global keyword. Global can be used to introduce a binding from the global scope into another scope. So in our example, if we wanted the function local to modify the global binding for message rather than creating a new one, we could use the global keyword to introduce the global message binding into local. Let's do that and see the effects. First, let's use the global keyword to introduce the module level binding of message into the function local. If we run this, we can see that the module level binding of message is indeed changed when local is called. Again, the global keyword should be familiar to you already. If it's not, you can always review Module 4 of the Python Fundamentals course. If global allows you to insert module-level name bindings into a function in Python, how can you do the same for name bindings in enclosing scopes? Or, in terms of our example, how can we make the function local modify the binding for message defined in the function enclosing? The answer to that is that Python also provides the keyword nonlocal. Nonlocal inserts a name binding from an enclosing namespace into the local namespace. More precisely, nonlocal searches the enclosing namespace from innermost to outermost for the name you give it. As soon as it finds a match, that binding is introduced into the scope where nonlocal was invoked. Let's modify our example again to show how the function local can be made to modify the binding of message created in the function enclosing by using nonlocal. Now when we run this code, we see that local is indeed changing the binding in enclosing. It's important to remember that it's an error to use nonlocal when there's no matching enclosing binding. If you do this, Python will raise a syntax error. You can see this if you add a call to nonlocal in our function local, which refers to a non-existent name. When you try to execute this code, Python will complain that no such name does not exist. Like global, nonlocal is not something you're likely to need to use a lot, but it's important to understand how to use it for those times when it's really necessary, or for when you see it used in other people's code. To really drive it home, let's create a more practical example that uses nonlocal. In this example, the makeTimer function returns a new function. Each time you call this new function, it returns the elapsed time since the last time you called it. Here's how it looks. And here's how you can use it. As you can see, the first time you invoke t, it returns nothing. After that, it returns the amount of time since the last invocation. How does this work? Every time you call makeTimer, it creates a new local variable named lastCalled. It then defines a local function called elapsed, which uses the nonlocal keyword to insert makeTimer's binding of lastCalled into its local scope. Elapsed then uses the lastCalled binding to keep track of the last time it was called. In other words, elapsed uses nonlocal to refer to a name binding which will exist across multiple calls to elapsed. In this way, elapsed is using nonlocal to create a form of persistent storage. It's worth noting that each call to make timer creates a new independent binding of last called, as well as a new definition of elapsed. This means that each call to make timer creates a new independent timer object, which you can verify by creating multiple timers. As you can see, calls to T1 have no effect on T2, and they are both keeping independent times.